Dear engineers, welcome to SAIMEDHA Koti Hyderabad. For the upcoming GATE, Polytechnic lecturer and ESC exams, SAIMEDHA Koti Hyderabad has taken an initiative known as Formula Series, in which we will be discussing the formulas in each and every subject. As a part of it, now I am going to discuss Nyquist rate calculations, which is useful for EC students in the subjects called communication and signals and systems, and it is useful for electrical students while preparing for signals and systems. So Violet, let's start. Now the topic for the discussion is Nyquist rate calculations. Nyquist rate calculations. I am pretty much confident that if you are able to follow this topic, definitely you are going to get a question either in your GATE exam, Polytechnic lecturer or ESC exam. So let's see how to calculate the Nyquist rate given any type of signal. First of all, you must know how to calculate the Nyquist rate. See, Nyquist rate calculation involves only one step. To the time domain signal, apply Fourier transform. From the Fourier transform, get the highest frequency component. Twice the highest frequency component gives you Nyquist rate. For example, if I am going to take a signal like this, x of t is equal to sine at by pi t. This is the signal I am going to take. Now what I said, if I want to calculate the Nyquist rate, for this signal I must apply the Fourier transform, right? Fourier transform of this signal will be, you must remember the Fourier transform for this signal. This is an important signal. So rectangular pulse varying from minus a to a in frequency domain omega. So this is the Fourier transform. Now Nyquist rate when calculated in radians per second, so twice the highest frequency component. Twice the highest frequency component means 2a. Suppose if you are going to calculate the Nyquist rate in hertz, simply divide this 2a with 2 pi. So a by pi. In this way you are going to calculate the Nyquist rate. For example, if I take this signal xt is equal to sine 4000 pi t by pi t. I want the Nyquist rate. How to find out the Nyquist rate? I told you, apply Fourier transform, from that get the highest frequency component. Now this signal and this signal are in the same form. What is there in the place of a? 4000 pi. So the Fourier transform of the given signal will be rectangular pulse varying from minus 4000 pi, 1000 I am denoting by k, to 4000 pi. Now Nyquist rate would be in radians per second, twice the highest frequency component, 8000 pi. 8000 means k, pi, radians per second. And if you want in terms of hertz, divide this with what? Divide this with 2 pi. Now what will happen? 4000 hertz, 4000x. And if you want Nyquist interval, if they ask Nyquist interval, 1 by 4000 seconds, right? Suppose if this question is asked, x of t is equal to sine 4000 pi t by pi t whole square. I want the Nyquist rate for this one. How to get the Nyquist rate? Here, look here, whenever you are going to answer the question regarding Nyquist rate, you must be in a position to apply some principles from Fourier transform and LTI systems concepts also, right? Now how can I write sine 4000 pi t by pi t whole square? Can I write it as sine 4000 pi t by pi t multiplied with sine 4000 pi t by pi t, isn't it? Yes, right? Now we know what is the Fourier transform of sine 4000 pi t by pi t. What is that? Rectangular pulse varying from minus 4000 pi to 4000 pi. Just now we have seen, right? Now the Fourier transform of this signal would be again rectangular pulse varying from minus 4000 pi to 4000 pi, right? Now I must get the highest frequency component, means I must calculate the Fourier transform. Now if you observe, these two signals are multiplied in time domain, means in frequency domain they are convolved. What is the convolution of two rectangular pulses of equal widths? Triangular pulse. So the Fourier transform of this sin 4000 pi t by pi t whole square would be a triangular pulse. And remember, the range of this triangular pulse is, see, the range of output in convolution is from sum of lower limits to sum of upper limits. So this triangular pulse exists from minus 8000 pi to 8000 pi, from which I can catch my highest frequency component, 8000 pi. So Nyquist rate is what? 16,000 pi radians per second. If you want in terms of hertz, divide with 2 pi, 8000 hertz, right? Nyquist interval 1 by 8000 seconds, that's it. In this way you are going to calculate the Nyquist rate and Nyquist interval. Now extending this topic, look here. If I ask you what is the Nyquist rate of sync T? Sync T Nyquist rate I want. Many times this is very, very important. See, sync T means Fourier transform, you must know. See, sync T Fourier transform is rectangular pulse varying from minus pi to pi. Please remember this one, rectangular pulse varying from minus pi to pi. So I got the highest frequency component. So twice the highest frequency component gives you Nyquist rate. So Nyquist rate in radians per second, Nyquist rate in hertz. So in radians per second it is 2 pi radians per second. In terms of hertz, 1 hertz. 1 hertz. If I divide this 2 pi with 2 pi, 1 hertz, right? See, if I ask you sync 2t, Nyquist rate. Okay, so you have to use the time scaling property of Fourier transform. This corresponds to compression in time domain. So in the frequency domain we will have expansion. So expansion, if you apply the time scaling property, so the Fourier transform will exist from minus 2 pi to 2 pi. This is 1 by 2, right? Now for Nyquist rate calculation, what is required? Highest frequency component is required. What is the highest frequency component? 2 pi. Twice the highest frequency component, 4 pi radians per second, or it is 2 hertz. 2 hertz. Suppose if I ask you for sync 3t, so Fourier transform would be rectangular pulse varying from minus 3 pi to 3 pi. Minus 3 pi to 3 pi. This will be 1 by 3. What is required? Highest frequency component is required. So this is 6 pi radians per second, twice the highest frequency component. So 6 pi radians per second or 3 hertz. 3 hertz. If you want to generalize, sync of mt I want. Sync of mt. So mt means the Fourier transform would be a rectangular pulse varying from minus m pi to m pi. 1 by m. Highest frequency I want, m pi. Twice the highest frequency, 2m pi. Twice the highest frequency component gives us the Nyquist rate. Now, in terms of radians per second, suppose if I want in terms of hertz, it is simply m hertz. So in this way you are going to calculate, right? Now let us extend this concept further. Again, if I ask you sync T, just now we have seen, no, sync T means, see what is the Fourier transform? Rectangular pulse varying from minus pi to pi. So Nyquist rate in radians per second is, it is 2 pi radians per second or 1 hertz. Okay, suppose if I ask you for sinc square of t, sinc square of t. So sinc t multiplied with sinc t, multiplication in time domain, convolution in frequency domain. So two rectangular pulses will be convolved in frequency domain. So triangular pulse you are going to get. Range of output, sum of lower limits to sum of upper limits. Right? Highest frequency component I want, 2 pi. So what is the Nyquist rate? 4 pi radians per second. Wow, this is 2 hertz. Suppose if I ask you for sinc cube of t, sinc cube of t. Sinc cube of t means sinc square of t multiplied with sinc of t in time domain. In frequency domain, convolution. So these two signals must be convolved. What happens if you convolve these two signals? Some shape you are going to get. Shape is not important, but limits are important. Limits means convolution. See, multiplication in time domain, convolution in frequency domain. So sum of lower limits to sum of upper limits. So minus 3 pi to 3 pi. So Nyquist rate 6 pi radians per second. In terms of hertz, 3 hertz. Right? Now we can generalize like this. Sinc power k of t. Sinc power k of t means its Fourier transform would be some signal which ranges from minus k pi to k pi. Minus k pi to k pi. Right? Now 2k pi radians per second or k hertz. K hertz. Hope you are comfortable. Right? Suppose if I ask you for this one, sinc power k of mt. Wow. Sinc power k of mt. See, sinc of mt we have seen, sinc power k of t we have seen. Now I want sinc power k of mt. Simply its Fourier transform. See, sinc mt, sinc mt, sinc mt multiplied how many times? K times. K times means convolution will be done in frequency domain. So here minus km pi, this will be to km pi, this point. So Nyquist rate would be 2 pi into km radians per second. In terms of hertz, km, that's it, km hertz. Right? Now observe here, I will extend like this, I will extend. So let us move this one upward. Hope you are comfortable with this. Right. Now if I ask you a small question from this, sinc power, sinc cube of 100t, if I ask you, sinc cube of 100t, what is the Nyquist rate? See, sinc power k of mt, Nyquist rate would be 2 pi into km. So sinc cube of 100t. So directly you can write 2 pi multiplied with 300. So 600 pi radians per second, or it is 300 hertz. Simply 300 hertz. In the same way, suppose if I ask you for one more signal, sinc power L of nt. So its Fourier transform again is some signal. So in the place of k I am having L, in the place of m I am having n. So minus ln pi to some ln pi. So Nyquist rate would be 2 pi into ln radians per second, or this is ln hertz. Right? Now again extend, very simple, again extend. Now observe here. Here I will try to make use of these two, this one and this one, sink power K of mt and sink power L of nt. Now I want the Nyquist rate of, observe here, sink power K of mt multiplied with sink power L of nt. Very simple. Now here multiplication is done in time domain. See, Nyquist rate we have to calculate, means we must get the Fourier transform, because from the Fourier transform, from the frequency domain only we can get the highest frequency component. Now these two signals are multiplied in time domain, means in frequency domain convolution will happen. So convolution means here this signal and this signal will be convolved. Convolve means what? Some signal you will get, but range is important. Sum of lower limits to sum of upper limits. So sum of lower limits to sum of upper limits. So if I add these two and multiply with the 2, it is 2 pi into, wow, Km plus Ln, Km plus Ln radians per second, radians per second, and in terms of hertz, Km plus Ln, Km plus Ln, that's it. Because these two signals are multiplied in time domain, means frequency domain, these two signals will be convolved. In convolution, output ranges from sum of lower limits to sum of upper limits. So these two must be added and multiplied with the 2. That's what I did. Right? Suppose for example, if I ask you the Nyquist rate of one signal, sink power, sink cube of 100t multiplied with the sink square of 200t, if I ask you. Compare, in the place of K 3, in the place of M 100, in the place of L 2, in the place of N 200. So Nyquist rate would be 2 pi Km plus Ln, 300 plus 400, 700 radians per second, or it is simply 700 hertz. So in this way you can calculate. Suppose instead of this, if I ask you this one, sink power K of mt convolved with sink power L of nt. If I ask you this, what will happen? Here these two signals, this signal and this signal, are convolved in time domain, means in frequency domain multiplied. Multiplied means this Fourier transform and this Fourier transform will be multiplied. What happens if you multiply? So if you multiply these two, the resultant signal after multiplication will come to a value which is the minimum of these two, minimum. So here I can write, so minimum of these two, so minimum 2 pi to minimum of Km comma Ln radians per second, isn't it? Minimum, because for example, observe here, one signal is like this, -1 to 1. If the other signal is from -2 to 2, if I multiply, see here time domain convolution means frequency domain multiplication. If I multiply these two, the output signal, the resultant signal will come from -1 to 1. So 1 is minimum, no, here minimum. So 2 pi into minimum of Km comma Ln. So in terms of hertz, minimum of Km comma Ln hertz. Right? Suppose if I ask you one example, if I ask you, so sink cube of 100t convolved with sink square of 200t. So what will be the Nyquist rate? Here 2 pi to minimum of Km Ln. So this is 300, 400. 300 comma 400. What is the minimum value? 300. So 600 pi radians per second, or this is 300 hertz, minimum of Km Ln. Right? Hope you understood this one. Now if I extend and ask you one more question, sink power K of mt plus sink power L of nt. If I add, what will happen? If I add, see, addition in time domain, so in the frequency domain also addition. So addition means here it will go to a maximum value. Suppose if you observe here, look here, if I have these two signals, if I add these two signals, the resulting signal will go from -2 to 2. Up to 2 means maximum, up to maximum value it is going. So here I can write 2 pi maximum of these two, Km comma Ln. So in terms of hertz, maximum of Km Ln hertz, maximum of Km Ln hertz, right? Now observe here, sink cube of 100t plus sink square of 200t. If I ask you, plus means, so 2 pi into maximum of what? Maximum of 300 comma 400. So maximum is 400, so it will come out to be 800 pi. 800 pi radians per second, or if I divide with the 2 pi, or maximum of 300 and 400 means 400 hertz. 400 hertz, right? So in this way you can calculate, and you can extend, you can still extend. See, if I ask you for this one, see these three I got, no? From these three, look here, if I ask you sink mt multiplied with sink of nt, if I want. So K is 1, L is 1. So here what will happen? K is 1, L is 1. So here 2 pi into this one, here it will come. 2 pi into K is m plus n radians per second, Nyquist rate, and here in terms of F, m plus n hertz. Wow. Suppose if I ask you for this one, sink of mt convolved with sink of nt. So convolution means minimum 2 pi into K is 1, L is 1, no? 2 pi into minimum of m comma n radians per second and minimum of m comma n hertz. Suppose if I ask you for this one, sink of mt plus sink of nt. So this we have to have 2 pi into maximum of Km comma Ln, but K is 1, L is 1, no? So 2 pi maximum of m comma n radians per second, or this is maximum of m comma n hertz. In this way we are going to calculate the Nyquist rate for some signals, and if you are going to follow this series, this formula series, and as a part of it we are going to discuss the first topic is this one, no? Definitely guaranteed question either in your GATE exam or Polytechnic lecture or ESC. Okay, so please follow the formula series, and I hope that you enjoyed this session. Thank you.